Hi, Prince here, and today I'm going to show you a new model. But before that, let me tell you a little bit of a story. So, for the longest, OpenAI has had GPT-4, released March of last year. This model has been the best large language model available. Everyone tried to compete with them, compare themselves with them, but they failed. But that's, of course, until 9 months later, in December, Google announced Gemini, their most ambitious large language model project. And they claimed it was better, or at least tried to compete. But according to, of course, early results, it wasn't as good. People didn't really like it, and there was a big gap between GPT-4 and the Gemini models. They recently released the Gemini 1.5. It has its highlights, but we can't necessarily say it performs better than GPT-4. But that changes today. Today, I'm going to show you a new model, a new competitor in town, and we are going to use these new models, both the text and the vision model, to extract information from large documents. So let me show you how. All right, let's get started. So a little bit about Claude 3. Claude 3 is developed by Anthropic. Anthropic is one of the biggest LLM providers alongside OpenAI, Google, and many more. And they just released their newest model, Claude 3. It comes in three sizes, as you can see here. You can see here the Haiku, which is the fastest they have, sort of like GPT 3.5 Turbo, although this one is better in terms of performance. Then you have Sonnet, which is a balance between performance and accuracy. You can think of it as like GPT-4 Turbo. And then they have Opus, their pretty much flagship model that competes with GPT-4 and all the other big models out there. And by the looks of it, this one outperforms GPT-4. And I'll show you the benchmarks and you'll be able to see it for yourself. But I would always say, beyond benchmarks, always do your own tests and see if the model performs the way you want it in real life with real use cases, which is what we're going to do here. In terms of tools, you're going to use Langchain and Anthropic's LLM API. So all you need to kind of install these is just pip install Langchain, Anthropic, PyPDF for our PDF, Langchain community, Anthropic API. So this is their kind of package, and Python.env. Python.env here is optional. You can use this if you're setting up your environment variables in a file like the way I did, but it's pretty much optional. One other thing that I didn't mention is that when I set images is because these models will also come in a multimodal variant that allows you to process both images and text. And we will go through that as well. So first thing you do is to import the libraries. In this case, I'm importing just getPass if you're going to pass the API directly to OS, or you're just gonna load this environment variable that you define in this file here. And importing preprint, this is just gonna help us print the text in full and we'll be able to see it. So here the interesting part starts. As you can see, Claude 3, according to their benchmarks, outperforms all of these models here. So compared to GPT-4 and the MMLU, it kind of performs quite close. But if you look at, for example, graduate level reasoning, it really outperforms these models by a mile. If you look at grade school math, where Google created this kind of 32 examples to come up with this result, GPT-4 only took 5 examples. Claude 3 Opus got a 95%, which is better than anything that came before, with 0 shot, meaning without any examples. Just by asking it to do the thing, it did really well. Same thing for Sonnet, that has really solid performance as well, and Haiku, which kind of just pretty much obliterates GPT-3 and is closer to GPT-4 and Gemini 1 Pro. Actually better than Gemini 1 Pro. Then you have stuff like GSM. Again, all of these other examples, when you see 8-shot, 1-shot, 3-shots, they kind of have examples on how to do this. Here, without any examples, this model performs really well, and so is the entire family of models. Now, a few characteristics or capabilities of this Claude 3 family of models is one, it has better capability of reasoning and analysis. It has better content creation. I tried it myself today, and it really worked well. Code generation, I haven't tried it quite yet, but it did create great prompts. So let's see. I'm going to try code generation later on because, of course, I'm coding a lot. So I might want to test it. And then there's a low resource language understanding. So there was this tweet from someone, I think I will post it in the comments or in the description below. This person took a low resource language, like I forgot the name, it's a very complicated language, and they managed to pass on a few examples, like 5,000 examples, and Claude 3 Opus, the best performing model, was able to infer new words and how to kind of create sentences just from a few examples. Another one is 15% less refusals or fewer refusals. Refusals in the sense that if you ask the model to do something before, it was more likely to say no because it didn't understand. Even if the request you had was harmless, it would still refuse. This model is 15% less likely or more. There's like a range. Then they have a 20% improvement in accuracy, kind of twofold, on open-ended questions. So if you ask it a very open-ended question, the model is more likely to give you correct answers. And I did this myself, and the model really performed well. Then they have a 200,000 context window. Like, that's a lot. 200,000 is a lot. You could fit in a few, like more than 15 pages of a document to the prompt, and it would be a no-brainer. And on top of that, this model has near perfect recall. So the Opus, the biggest model, can recall any sentence or keyword within that context with almost near perfect accuracy. So you can think about in the 90%, 99% plus. So if you ask it to retrieve a particular piece of information within this 200,000 token prompt, it's more likely to do that compared to other models out there. And they also are offering up to 1 million tokens for selected users. So this is really interesting stuff. This kind of comes before, for example, what Google did with Gemini 1.5 Pro. It has a 1 million context window and it opens up incredible use cases. Then they have Haiku, their blazing fast model. They have an interesting claim for this model where they say it can process up to 10,000 tokens, right, with images in under 3 seconds. That's a big claim. I cannot wait to try this out, but it's not available for the API. Now, let's really get started with our example. You can read more here in this link. I link it to the paper. You can go just read more. So just to test it out, let's try a simple prompt. We are using Langchain here, so chat prompt template, and they already integrated with the Anthropic API. So this is kind of a wrapper on top of the Anthropic API that gives you all the capabilities that are already in the Langchain ecosystem. So you can use prompt templates. In this case, we are using a simple one. We have a system message that says, "You're a helpful assistant that responds like Snoop Dogg," and we're going to pass on a message. And in this case, we're going to use Sonnet. I would like to use Opus, but it's pretty expensive. You can go check on the website. It's pretty expensive. The output tokens are 2 to 3 times more expensive than GPT-4. And since we are processing large documents, I want to avoid any extra costs. So after we define our prompt, our model, we're just going to create a chain using Langchain expression language. So first you just pass on the prompt, pipe. We have this pipe syntax here, and we pass on the chat. What this is going to do is going to put the prompt before the chat. So whatever message we pass on here, it's going to format into this prompt here and then pass it to the model. So then we're just going to call invoke, and here's our initial output. So I said hi. And the model responds, clears throat and speaks in a Snoop Dogg-esque voice. What's cracking, my human homie? The DOJJ is here to kick some knowledge your way for shizzle. You already know I got mad respect from them copyrights, so you ain't gonna worry about me dropping no lyrics or quoting whole books and such. That's a no in my book, you dig? But if you hit me with a document, I will break it down and give you a 411 straight up. Just holla at me, what you need, and I'll lay it down smoother than a Snoop Dogg track. This response, I guess, is the best Snoop Dogg response from any model I've tried. I tried Gemma, I've tried Gemini, I tried GPT-4, all of them. And this is the funniest and the kind of most accurate response I've seen. Not accurate in the sense that it's veridic, but it just sounds so real. So let's move on to loading our file so that we can do data extraction now. Here we have our load file function. It's similar to the one we did before with Gemma. If you watch the previous video, the Gemma video, we already do this. But the difference is because we have a bigger context window, we don't have to split our pages into smaller chunks. We just load everything. Here is the function. Let's load the document. There it is. And let's look at the pages. So here we have the first page is the Claude 3 family model. It's kind of just giving you the abstract, and the document is this one here. So this is the Claude 3 report paper, and you can see that it pretty much matches what we have there. And I chose to only load 10 pages also to avoid extra costs. We could go for the entire document, but I think just the first 10 pages we can get the point across. So there we go. The next thing I'm going to do is that I'm going to turn this document into a kind of XML format. Claude 3 works really well with XML. If you want to do data extraction or function calling, you might want to use XML. It's kind of what they recommend. So instead here of just passing this page content, we're going to turn this page content into XML pages list. So if we look at the prompt here, we are now gonna see that there is a page number 0 with the information and so on and so forth. So how does this plug into the bigger picture? We are now gonna create the prompt that we are gonna pass on to Claude 3. So here's the prompt. Please carefully review the given research paper and extract the following key details, enclosing them in the specified XML tags. So the first tag is the title of the research paper, should be enclosed in title, right? Tags. Then there is the abstract or summary of the paper, should be enclosed in abstract, right? And then here's an interesting one where I was really pushing the demo example they gave. They don't get close to doing something as complex, but here's what I did. So first, we want any mentioned models or techniques enclosed in model tags with their respective capabilities or applications nested in capabilities and capability tags. On top of that, we want any benchmark results of said models to be enclosed in benchmarks and the nested within the next nested model tags, and it should use benchmark and score. So what's happening here? It's a very interesting question. So here's an example of what I want the model to do. I want it to extract the title, abstract, and then within model, I not only want the name of the model, I want the capabilities of the model, and I want the benchmarks with the name of the benchmark and the score they got. Why is this hard? So the model has to read through the entire prompt and catch this information at different pages of the document. This is particularly hard. I think GPT 3.5 Turbo would have a hard time doing this. I haven't tested GPT-4 on this particular kind of format, but I want to try it. I think it's gonna have a hard time, simply because it's not just a single. How do I say? It's not a simple because the benchmarks are later compared to the model. So there's model capabilities and then benchmarks at the end. And for the model to kind of figure all of this out and aggregate it into this format might be really, really hard for a basic model. So here's another example. So model A, model B, and also please ensure that the extracted information accurately represents key details from the paper. If any of the requested details are not explicitly mentioned or available in the paper, leave the corresponding XML tags empty. And then I pass on the document here, where I use the tag document to enclose the pages. So it's going to be document, and then within it's going to be all the pages within that document. And I pass that on here into the human side, and I ask it, the system prompt is very simple. You're a helpful assistant that returns XML. That's it. Then I'm going to pass on pages as I defined here with Langchain to the document extraction chain. And here's what I got. So it got the title correct. If we were to do this in parallel, for example, I think it would have been also a bit troublesome because you're doing page by page and the information you are looking for might be scattered across pages for a particular tag. I don't know how the model would handle such a thing. I think you would need to orchestrate these. So that's why in a single prompt, it's much easier to do. But here's the great thing. So it caught the title, right? It didn't repeat the title, which in the past I've experienced this when doing document extraction. It got the title right, a single title. It got the abstract right. It got a single abstract here. Perfect. And it's kind of word for word of the abstract. Yes, exactly. Then it found the model. So let's look at the models here. So the first model is Claude 3 Opus. Correct. Capabilities, reasoning, math, problem solving, coding, reading comprehension, question answering, multimodal input, image and text. Correct. Great. Now let's look at the benchmarks, what it found for benchmarks. GQA benchmark, it got 0 shot, 50%. It got this result correct, but it made a mistake, I guess, here. Because let's look at the image we got earlier. Yeah, it made a mistake there, but it did get the first one correct. I think I would need to kind of prompt it a little bit more, but it did a good job. And of course, this is a hard task. Then it showed for math, it got the first result correct, but it kind of also included some other information from other columns of the table, which I think is a mistake of these two first lines. And then the second one, third one, whereas human eval, it got it correct. Everything else, it seemed to have done correctly, except here with PubMed, it also made a mistake. But yeah, it did really well extracting this information, and you can load this anywhere. And it also did the same thing for Sonnet. It caught the model correctly and the capabilities, but since the number of tokens, output tokens, is limited, it kind of stopped generating. But we could, let's say, generate 4,000 tokens and just continue this response. Now, that's document extraction. We did this with a PDF. Now let's do this with an image, which is a bit more complex. If you have ever tried Gemini or GPT-4 Vision, you will notice that, for example, GPT-4 Vision didn't perform really well with text, like translated text. If you ask it to translate a weird language like Arabic, it might have flaws compared to Gemini. Gemini, when it came to text, it really translated really well, but in some cases of like tables, it would have trouble. Now let's test Claude 3 and see if it has the same issues. So here are the benchmarks. You can look at, here are the benchmarks for the vision versions of these models. You can see that the Opus seem to be pretty much close to performance when it compared to Gemini Ultra on the in the MMU benchmark. Then it seems to be close to Gemini Ultra as well when it comes to document visual QA. It loses, but still relatively close when it comes to math visual. When it comes to Math Vista, which is another benchmark, and when it comes to like diagrams, Claude Sonnet and just the entire family of models here outperform all of these models. So if you have a diagram within your document or your image, this kind of so if you have a diagram within your document or image, these models are more likely to perform better than the others. And then you have charts as well. It also performs on par with Gemini Ultra, with the Haiku model outperforming Gemini Ultra, which is pretty interesting. Now, this API for the image, for the vision models, supports mostly base 64 images. So first thing we will do is load our base 64 image. In this case here, we're going to use pathlib. I'm just passing the image here, which is the high quality image. And I'm reading that image, and the image is going to look like this. This is a screenshot from the paper, right? It's a table. I wanted to make it a little bit challenging to see what these models are capable of. So first we're just going to load this, right? This big image here. And the prompt is similar to before, but there are a few differences. So instead of document, we say image. And we remove the first two of like abstract and title. And here we only care about two things, the model and the benchmark. So the prompt remains the same. The example, we just cut the first two and just remain with these ones here, where it's model A, benchmark name, score. That's it, right? And then this last line is the same as before. And the prompt changes as well. So instead of just passing on this text here, we want to be able to pass the image alongside the text. So this is going to be a list of messages here where it has both the text and the image. And I'm using the prompt template, so I can just then create my chain. And after I create my chain, I can pass on here input, which is going to be the text, and image, which is going to be the image here. And if we run this, wait. So a minor correction here, we are actually going to hard code the image here. I tested this out. It turns out that it's hard to pass this through the chat template. Something I have to check with the Langchain docs or the community. But yeah, I'm just gonna hard code this base 64 details here, and then I'm gonna pass on this input, which is gonna be our prompt here. So I'm gonna use the input tag and create my chain. After that, I'm just gonna run this. Wait, I need to run this. And now this. There we go. Now it's running. It's taking the image alongside with the prompt and extracting the details. This is a bit slow with Sonnet. I cannot wait to see how much faster Haiku is. But here we got the result. It took around 23 seconds to extract from this image. So let's look at the details. Image description, it chose to create this tag and also create a table. But let's look at it. It has the name of the model, which is header. It got the 3 models correctly. It got GPT-4 and 3 correct. It got Gemini. Okay, this is all correct. Let's see here the results. This row has all of them, but the second one has only 3 results. Yeah, so here are the 3 results. And if you look at this table, it's supposed to be here. So if you look at this table, you can see that we only have the first 3 results and the other ones are empty. So this vision model managed to capture that, which is pretty interesting. So you can see everything else is empty. So that's pretty cool. And it got right the next row, and this also only has a few results and everything else is empty. So yeah, pretty much really great results from Claude here. And this is a very challenging image. Now let's make it even more challenging. I'm going to copy this code. Actually, I just need this code here, and we are going to load the low quality image. All right, there we go. This is a lower quality image. You can see here it doesn't look as good. So let's see how the model will perform in this use case. I'm going to just copy this image extraction here, down here, and I'm going to copy this one here. Okay. All right, so let's run it. And let's see what we are going to get. There we go. So now we have the results. And, oh, okay. So here we can start to see a few problems. It didn't catch the full name of the models correctly, but it did manage to get most of them correctly. Here it got the pro correctly, but now it created this 14 and 13 and 11. It kind of hallucinated these results, this results. And then it took the results. So let's double check these results. So it says 86, 79. Okay, it got the numbers correctly, and it did get the second part also correctly. It left the other parts that are empty. So mostly okay, but with a few hallucinations here and there. But it's still, I can forgive that. The model performs really well. The image was hard. So if you have a higher quality image, I suggest you use it. Now, a few interesting use cases to pursue here are function calling or tool calling. And you can check them out here in the Anthropic's documentation and Langchain documentation. And the code for this example will be in the description below, so feel free to check it out. And that's it. Thank you. See you in the next one.